Welcome to this lesson on atomic structure. Today, we will explore the fundamental building blocks of all matter around us. Everything you see, touch, and interact with is made up of incredibly tiny particles called atoms. Understanding the structure of atoms is essential to grasp how matter behaves and how different elements have their unique properties. Let's begin our journey into the microscopic world of atoms. An atom is the smallest unit of matter that still retains all the properties of a chemical element. Think of it as the basic building block that cannot be broken down further by ordinary chemical means while maintaining its elemental identity. Everything around us, from the air we breathe to the water we drink, from metals to living organisms, is composed of atoms. These incredibly tiny particles combine in various ways to form all the different substances we encounter in our daily lives. Atoms have a remarkably organized structure consisting of two main regions. At the center lies the nucleus, which is the dense core of the atom. The nucleus contains two types of particles: protons, which carry a positive charge, and neutrons, which have no charge. Surrounding this central nucleus is a region called the electron cloud. This is where negatively charged electrons move around the nucleus in specific patterns. Despite the nucleus being extremely small, it contains almost all of the atom's mass. Let's examine protons in detail. Protons are positively charged subatomic particles found in the nucleus of every atom. Each proton carries a charge of +1. The mass of a proton is approximately 1 atomic mass unit. Abbreviated as a MU, the atomic mass unit is a standard unit used to express the masses of extremely small particles like protons. What makes protons particularly important is that the number of protons in an atom's nucleus determines what element that atom is. For example, all hydrogen atoms have exactly 1 proton, while all carbon atoms have exactly 6 protons. Now let's look at neutrons. Neutrons are subatomic particles that, as their name suggests, are electrically neutral, meaning they carry no charge at all. Like protons, neutrons are located in the nucleus of the atom. The mass of a neutron is approximately 1 atomic mass unit, very similar to the mass of a proton. Neutrons play a crucial role in holding the nucleus together and adding stability to the atom. Different atoms of the same element can have varying numbers of neutrons, which creates what we call isotopes. Finally, we have electrons. Electrons are negatively charged particles that orbit around the nucleus in the electron cloud. Each electron carries a charge of -1. Unlike protons and neutrons, electrons have an extremely small mass, approximately 0 atomic mass units when compared to protons and neutrons. In fact, an electron is about 1,800 times lighter than a proton. Electrons are responsible for the chemical behavior of atoms because they are the particles involved in forming chemical bonds between atoms. The way electrons are arranged determines how atoms will interact with each other. Let's compare these three fundamental particles side by side. Protons have a +1 charge, are located in the nucleus, and have a mass of 1 atomic mass unit. Neutrons have 0 charge, are also located in the nucleus, and have a mass of 1 atomic mass unit. Electrons have a -1 charge, are found in the electron cloud surrounding the nucleus, and have a mass of approximately 0 atomic mass units. Notice that protons and neutrons have similar masses and both reside in the nucleus, while electrons are much lighter and occupy the space around the nucleus. Let's review the most important concepts about atomic structure. First, atoms are electrically neutral because they contain equal numbers of protons and electrons. The positive charges from protons perfectly balance the negative charges from electrons. Second, the nucleus, though incredibly small, contains nearly all of the atom's mass because protons and neutrons are so much heavier than electrons. Third, the number of protons in an atom's nucleus determines the element's identity. Change the number of protons, and you change the element itself. These fundamental principles help us understand how atoms form the basis of all matter in the universe.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.